Happy Friday. And I'm Rob Reed, Technical Evangelist at Cockroach Labs. I would think so. I think we need to be thankful that it is Friday. Yeah. Much more formal than yours. Yeah. Yeah, I guess today's gonna be all about quick wins for database performance. That was the title we gave it. It's gonna be more like how Rob screwed up back in 2014 and what he learned from his mistakes. Um, yeah, but it ultimately has to have come from some kind of wrong, and hopefully today rights it a little bit. I've done many. I've made many mistakes. Many, many mistakes. So whenever you are ready, do you want me to start sharing? So as I say, back in 2014, I created a database. It may have been the most immaculate database the world had ever seen. I tested it with every possible permutation you could imagine. So for every column value, I had it, every kind of column like value you might expect for that column. And I was ready. I was ready. I had about 25 entries in that database, and I was ready for production. I knew what I was going to face. I was. Little did I know how unready I was, like how hilariously unready I was, because I'd never really run into a production's like scale database before. Like I've been a software engineer since 2006, but I think it wasn't until 2014, maybe 13, 14, that I actually started dealing with like bigger data sets. And it took me off guard. Like it showed me that like it's not just coverage of testing you need to have, but it's also you need to test for load as well. So it was an eye-opening experience for me, and I want to walk people through the journey that I had way back when. I'm sure people are still making this mistake, and it's a really really easy one to make. And actually, with Cockroach, it's a really easy mistake to fix, which I'll also show. Oh, no, it's fine. Yeah. I think it was just, if I remember rightly, I think it was just reference data. So I worked in middle to back office in a finance company. And if you look on my LinkedIn, it'll be one of two. So, or one of three. So it's not, particularly sensitive, but it was a reference data to application. And I was testing it with all of the reference data I could imagine there would be, but I didn't imagine how much reference data there could be or the breadth of it. There was a lot of it and very varied. So what I'll do now, I'm going to just create a single instance of Cockroach. I'm going to start a single node. It's going to run in the background and it's going to run in secure. I don't need it to run securely because it's just me running and it's just my local machine. I'm then going to run a create and an insert into it, and then I'll hop onto the terminal. I'll show you what those are doing in a sec. I've created my table, I've inserted the data, and I'm ready to go on the terminal.
All right,
So
and just
there's
a
my
quick,
demo.
apparently my mic was not coming through. So if you hear me now in the chat, just let me know. But you can continue.
So the create created a table, two tables, one called product, which is a very vanilla product. It has an ID, which is a UUID primary key with a default value of a random UUID, a name, a market. So for example, if you're selling products in France, the market would be FR, the ISO 2 code for that country, an amount and a currency. And then there's an internationalization table, which stores the translations. So if, let's say a French speaker, I don't want to have to translate an English catalog into French. I want the catalog to do it for me. So that's created the two tables, and then I insert some data into it. So this is just a bit of known data. So this, if you imagine, was the data set I inserted when back in 2014, whenever it was, to test my application. So I was testing not only the database, but also the application that I had running on top of it, which is just a simple GUI in WPF. So I've got a bunch of different data here. So I've got 3 coffees for the UK, Germany, Singapore, India, US, and Mexico markets. along with their currencies and local exchange values. And then I insert the internationalization or translated values for those as well. So that's all that part of the script did. And then I hopped into the terminal. So if I do a search now, you'll be able to see this query here will select the translated value, the amount and the currency from the product table. It will then do an inner join on the internationalization table. An inner join, for anyone who doesn't know, being, if you imagine you've got two tables and you only want the subset of data that exists within both tables. So if there's data over here but not over here, it won't return it. If there's data over here but not over here, it won't return it. But if there's data that overlaps that portion, it will take it.
It's the classic interview question where it's like, describe an inner join, and so you totally make like the two circles and you overlap.
How difficult would that interview? It would be unpassable if you weren't allowed to make a circle with your hands. I don't know how I'd pass it.
I'd be like, can I draw?
Then I do a filter on the market, where the market is US, for example, and I want to see the results in Chinese. So that's what the data looks like. 3 milliseconds. I'm super happy with this. Let's ship to production. So let's do that. I'm going to run an API. This is going to be the next part. This is the application part of it. I'm going to just allow that to run on that port. So this is just a Fiber app, which looks like this.
So Fiber is just a way of creating like a RESTful API using Go.
Yes, exactly. Yeah, it's one of many, many, many ways. Like I think every waking minute there's a new web framework for Go.
Sure.
And there was actually a website created called New Web Frameworks today, and it counted the number of web frameworks created that day, and it was always more than one. So I create a connection. I pass in a connection string to the application. That is just my my local running database. I create a database connection pool. Then I create the router, the Fiber router, and it's listening on an endpoint called market. So this might be US, for example, product, and then language. It listens, and any requests that it gets, it goes to handle get products, which is essentially a function with a closure over the DB connection pool, and it returns a function. So there's a market here in the URL param, and a lang parameter in the URL params. I fail if I don't get either of them. And then I basically just run a raw SQL statement passing in the arguments. So where the market is market and the language is the lang thing I got from the URL params. Make the query, scan the results, and return it as a JSON blob. So let's do that. Let's just call it quickly. So I'll do a curl. Don't care about the output. Virtual host port 3000. The market is going to be, let's say, US, and it's going to be, what was the output? What was it? It was products. US
and
products.
We're not even talking about like a globally replicated database right now. This is just
a local
node.
Yeah. These what we're going to do here would be translatable to any size of database.
Great.
So that's the API working, all happy. I make a curl request, I pipe it into JQ, which just formats it nicely into JSON, and that's what I get. And if you run it, it's nice and snappy. So let's run a load test on that now. So I'm going to call a little function that I wrote in K6, which is an amazing load testing tool. You write your tests in JavaScript. I've got a bunch of markets here because I want to be able to request different markets to simulate reasonable usage. I don't have any sleep time, so it's going to do it as fast as it possibly can. It's going to select a random market from the markets array. It's going to build up an HTTP request. I could have probably done the same for languages, but hey ho. Actually, you know what? Let's do it. Why not? Constant languages.
We're live. I mean, why not?
Let's rock, indeed. Let's do. We've got 4 languages. One is Chinese. One is English. One is Spanish, and one is. And let's pick from languages as well. It will make the request. It will assert that it was a 200, and it will fail.
Do you need to do a const language equal random item language?
Yeah. Yes, I do. Thanks. That would have really confused me.
We're just passing a whole array in there. No worries. Unrelated, but I've always used raw SQL instead of using an ORM. So from the chat. Yeah, okay. I mean, use what works.
I've used both.
Yeah,
I've used both. I've used Entity Framework, which I found personally a little terrifying. I found it difficult to get right. I found it difficult to create joins and kind of grok what the database was doing. I knew what the database was doing because I created the database, but actually translating the database into code, I found really difficult with the use of an ORM. And also, if my query was slow performing, it wasn't really my query. I hadn't written the query. I just got a bunch of generated garbage. Obviously not garbage, but so I ended up using Dapper for .NET, which allowed me to write my own SQL statements, but still pass it to essentially plain old C# objects.
Nice. Yeah, I like to use an ORM that has an escape hatch, so that way, for the regular things, just simple reads and writes and things like that, you can use it. But if you have something that's a little more complicated, you can drop into some kind of raw SQL mode.
Yeah, I agree. I think I couldn't do the same with nhibernate either. I had to really debug it. It took a while. Anywho, we've got our load test, so let's run that. So I'm kicking this off. It's going to simulate 50 virtual users. It's going to run for 10 seconds, and I'm going to be using the JavaScript that I created. So you can see that in that 10 seconds, it's run on average 11,500 requests a second, totaling 114,000 requests, and they all completed roughly in about 4.5 milliseconds. So pretty good. Obviously, it's local, so you'd expect it to be sub 10 milliseconds. Now we deploy to production. And this is obviously where you would expect things to go horribly wrong. So I'm going to generate some data. The data is going to come from a tool that I wrote a while ago called DG, Data Generator. I'm going to generate data for a product table. I'm going to try and generate 1 million rows, but I'm going to make it unique on the name that I create. No reason other than, at least we know we've got unique names. So I'd expect, on average, I'd get about 820,000 unique products out of this. It will generate an ID, generate a name, which is comprised of an adjective, an adverb, and a countable noun, and you'll see that in a minute. A market, which is a random set from here. I can weight it if I want to, but let's just give them all equal weights. An amount and a currency. So I'll kick that off. I'll generate 1 million, or as close to 1 million products as I can, and then I'll serve up that data via a Python HTTP server. So listening on port 4000. I can now import that into the database.
And so this is generating it and storing it, or generating it for the database that's actually live, not local.
Correct. And in fact, I could show you. Let me just here we go. CSVs product. So that's what the data looks like. It's just a whacking great CSV file with I'd imagine 800 and something thousand lines. 824,000 lines.
Yeah.
Colombian most egg, Shakespearean occasionally chair, all sensible product names, as you would expect.
Of course.
So let's insert those now. That's them done. That's all 824,000 rows imported into Cockroach. If I select them out, you'll be able to see what they look like. Select star from product, limit 10. We've got finished weekly book, complete eventually animal, diabolical underwoman. These are some strong product names. Heavily regular cat. I would not want to be in ownership of that cat. Anywho, so I'll stop that running. And now I'm going to run the same query again. So the query that I ran initially, that ran in 3 milliseconds, I run again. So now I'm starting to panic. As a software engineer, I've just realized that we're live now, let's say, and my query is now taking over a second. It might take under a second this time because things will be cached, but we're around the second mark, which is obviously an order of magnitude slower than before. And in isolation, that's annoying for one user. But when that's compounded, let's say we've got one API and there's only one entry point into there. If I run the load test again, look at this point here. This is the bit we're looking at. This is where my cursor is. We've made 20 requests, 30 requests. So we've introduced a huge problem. There's a huge bottleneck here. So it should have finished by now, but it's still receiving requests back, so it's still going. And it will complete when it gets to 100 and then stop. So obviously the difference between 4.8 requests a second and 11,500 requests a second is quite stark. The average request time took 8.5 seconds, and that's because it was trying to make a request and it was just waiting. We can increase the size of the connection pool. That might help a little bit, but still, when every request is taking a second, we've got a massive problem. So how do we fix this? Let's run and explain. Firstly, I'll run and explain on.
Oh, tell us about this explain.
We'll explain it.
Yeah.
I will. Oh, but first, let me show you what Cockroach tries to do. This might be interesting. So let me go into Insights and then Schema Insights. So Cockroach has realized there's a problem. It's suggesting that I create indices on things. Like it knows that there's a problem. It knows the queries that I'm making, and it can also show the queries that I'm making in a way that doesn't, leak anything. So if there's PII here, you wouldn't see it in the UI. But this is the query I'm making, and it knows it's not optimal.
Yeah.
So I'll get back to that in a minute. For now, I'm going to pretend like I know better than CockroachDB.
Yeah, but Intelligent Insights, I believe that came out in like 22.1, but it's available for everyone, even if you're using serverless. You can go into your console and take a look at those and see how your database is performing. I go in there and look at mine every so often.
Super, super handy. But for now, I'll pretend like I know better, and I don't. So let's do an analyze. So what we're doing here is, I'm not going to pretend to know exactly what's happening, all of it, but essentially we're reading every single line. That's 64 megabytes, 824,000 rows from the KV store. We spend about a third of a second in the KV store, which is a lot of time to be just spending deserializing binary data. Then we're doing joins, we're doing filters, but most importantly, we're doing full scans. Now, if the cost-based optimizer in Cockroach will use full scans occasionally, if you're working across a really small table and it doesn't need to do indexes or anything like that, and it's just quicker to do a full table scan, it will do that because it realizes that's the cheapest way to run the query. But in a table of 824,000 rows, a full table scan is a big red flag. So it's not doing just one, it's doing a couple of full table scans here, one across the product table, one across the internationalization table. So it's not happy. And if it's having to do, imagine you've got 100,000 users and it's having to do a full table scan over 800,000 rows, increasing as time goes on for every single request, you're in a bad position. And you can cache it, but that's only masking the problem. So let's start making some improvements. So I'll go back to the Insights page, and that's telling me to create indexes. So it's asking me to create an index on the internationalization column. I'm going to ignore this bit for now, and it's going to ask me to create an index on the product. Again, I'll ignore this bit for now. I'll explain what those mean in a minute. So I'm going to put my I know better than you hat on, and I'm going to create some indexes. So I'm going to create an index on internationalization and product tables.
So for people who might be new, what is an index for a database?
Yep. So an index is essentially so in Cockroach, it's a lookup. It's an entry in the key value store, which says for this table and this particular index, let's say name, for example, you don't have to search through everything in the table. Like these are the values. It goes from this value to this value, and it allows Cockroach to do very, very, very quick lookups. So the primary key index, for example, that allows CockroachDB to basically do a point lookup to say, where's this value in my database? It knows exactly where it is because it knows which range it's in. It knows, so for example, in the case of a UUID, it will store things in ranges. So 000 to 001, for example, starting with a UUID. If I'm looking for a UUID that starts with 001, it will know that it's in the first range and it'll be able to find it super quick. Yeah. And the rest of the data is stored within that primary key index. So if I create a name index and I don't use what's called a covering index, which I'll use in a bit, Cockroach will do two lookups. It will use the name index to find the record, which will return the primary key, and then it will use the primary key to do a primary key lookup to get the rest of the data that you're requesting, if you're requesting any additional data. But essentially, indexes, good, use them, they speed up your queries. They might slow down inserts and updates and deletes. I'm not sure exactly which ones, basically the non-read queries, because it's having to insert more data to make your queries faster. So your write performance will take a very, very, very minor hit, and so too will your storage, because it's having to store more data. But the benefit you get from the read performance completely outweighs any of the costs.
Yeah, nice.
So I'm going to do the select again, and this time 6 milliseconds. So it's nice and snappy. 2 milliseconds, 3 milliseconds, problem solved. But obviously it's not completely solved. I will run the load test again though.
Okay.
And you'll see that rather than doing maybe 10, like 4.5 requests a second, we're now chugging away, and it's looking much, much healthier. But we can do a lot better. So we're making on average around 5,500 requests per second, and in totaling 57,000 requests. It's taking about 8.5 milliseconds to do each local request, which is good. But if I pop back into the terminal, refresh my screen just to make sure it's all. Oh, I nearly left the streaming call. So now it's asking me to replace an index. It knows that I've created an index on the internationalization and product tables, but they're not covering indexes, and it's asking me to delete them and create new ones. So I'll do that. I will concede to Cockroach. I will concede that it might indeed know more about SQL queries than I do, and I'll delete my 2 queries.
And so what is a covering index?
I will show you. So delete those 2 indexes first.
Okay.
Doing any reclamation of storage in the background, which is cool. And then I'm going to create 2 indexes. So what these indexes are going to be doing is I create an index on the product table, and I'm indexing the name and the market. So in the key value store, that will appear as name and then / market. So it'll be 2 logical segments sorted. And it's storing. So in the key value store, that index will be keyed off name and market, but it will store amount and currency. So if the only things I'm asking for are amount and currency from that table, I will get those without having to do another primary key lookup. So in the previous example of the I know better index, it was having to do a primary key lookup because it could find the name or whatever I was asking for. I think I might have even keyed it off name and market. But then it was having to use the primary key that it found to do a primary key lookup to bring the rest of the data back, which was, in this case, amount and currency. And I'm doing exactly the same. So whenever I do a lookup on the internationalization table, using the language, I'm returning the translation.
Got it.
So the language might be lang would be EN, and I'm returning the translation for, let's say, cappuccino.
So all the information that we're looking to return in that query is actually stored with the index, right? And
yes.
So we're cutting out a whole lookup, basically.
Yeah, exactly. So I'll create those 2 indexes, and I'll get ready to run that select again. And let's run a query. So 4 milliseconds, 1 millisecond, 1 millisecond, 2 milliseconds. Still nice and snappy. Let's run the load test again. So 114,000 requests, 11,500 requests a second, totaling 114,000. So we're actually back to where we were before with a tiny table. So we're achieving the same level of performance with a table that contains 824,000 rows that we were achieving before with, I think, 20 rows. So very, very good performance. And if I do an explain over that, there's 2 different types of, there's loads of different types of explains you can run. One of them is explain, analyze, and actually there's analyze and analyze. They're both aliases of one another. So now, I should have done an explain before I created the covering index, but what we'd have seen was 4 blocks. It would have done the lookups, and then it would have done a primary key lookup for both cases. Now they're super, super quick, so it didn't really add much to the, what we actually saw. We were getting 57,000 requests in 10 seconds. That ramps up over time. It's not just like it does ramp up to 50, 50 virtual users, but we've pretty much doubled our throughput by not having to do that primary key lookup. And this one's just doing 2. It's doing a lookup on product based on the based on the name and market or something like that. Doing it super quick, and then it's joining straight on to the internationalization and returning the values it needs. And this means it's doing scans. It's not doing like full table scans. So it's really, really quick. So I'm going to now scale this up a little bit. So I'm going to generate some more data. You can get another 820,000 rows.
Oh yeah, and this is adding more products, right?
Yep, exactly. I'll insert those products. So let's do a count star. Let's see how many we've got now. 4 million. So we've got quite a lot of products now. Let's just do another select just to see how we're looking from a query by query perspective.
Okay.
3 milliseconds, 3 milliseconds, 2 milliseconds, 1 millisecond. Nice and quick. Let's run a load test. $125,000. So it's actually faster. It's only that there are other variables at play here, but it's not linear. As the database gets larger, our queries don't get slower because it's indexed. Cockroach knows where to get things from, and everything remains super snappy. So as the database gets larger, we don't get slower. And I think that's probably most of the things I wanted to show. A couple of things to maybe mention in addition to that. We normally say that anything over 100 milliseconds should be alarming to you, and that's because 100 milliseconds is generally accepted as the time at which a user can perceive a delay.
Okay.
So if you're asking for a product, you're having to wait, let's say 200 milliseconds. It's okay. It's all right. Okay, it's all right. Like you're realizing there's a delay and it gets annoying, and especially imagine if you're scrolling through products and every couple of products you hit a bump, and it will get frustrating, and you could lose customers because they're just not happy with that. They want immediacy.
And that's like you said, 200 milliseconds, like total, not just for grabbing the data, but to render everything. So,
that's a good shout.
Yeah. So it's helpful to get the data reads as quick as possible, so that way, anything left in that 200 milliseconds can be used for, the server doing some more processing, passing it to the front end re-rendering, things like that.
Yeah. So it makes sense for every part of your stack to be as quick as it possibly can be. And this query here, I just want to show you some of the cluster settings that I've got where the variable contains threshold. So for example, this one, we will start generating insights for queries when they take over, or I think maybe 100 milliseconds or over. So had that have been any higher, let's say 8 seconds, we wouldn't have generated an insight for that. So it's configurable. You can set this value, and I think it's as easy as set cluster setting blah equals, let's say we want to make it 50 milliseconds. That'll be a string. There you go. So now if I run a query and it takes longer than 50 milliseconds, Cockroach will start to consider it for insight analysis. So you can always keep track of queries that you consider to be slow for you. So as you mentioned, that's end-to-end round trip 100 milliseconds. If 100 milliseconds database time is acceptable to you for a query, then fine. But if the rest of your stack is taking an additional 100 milliseconds, now you're starting to become noticeable to the users. And there are other queries as well. So I'm now showing, if you run show full table scans, I can now show anything that's doing a full table scan. So my select star from product performed a full table scan. It will show you the number of rows read, 2.4 million, the number of bytes read, what was that, 199 meg? Not sure exactly what that is, but it's a lot of data.
Yeah.
And eventually that will go. It will hit the statistic time drop off, and that will go. But ideally, this would never return results. If you're running select star, of course, it will. But for most use cases, for most of your queries, they'll end up in here, and I think in the front end, if they're generating full table scans, which is quite a useful metric to see as to the general health of your queries.
Yeah, I remember like working with my backend person and be like, I need to be able to show the number of subscribers, and he's like, I can't do that. He's like, that would just make the query too slow because full table scan, and I didn't really understand it until I started working in the database space, and so I'm like, oh well, yeah, of course. From the chat, we've got if I get to design the table, I try to design it around how I'm going to query it, so you can use techniques like this. Sometimes you're just stuck with what's already there though. So what we are talking about right now is very greenfield. Like you have complete control over the query. Do you have any like experiences or anything around like coming into something that was already existing and seeing what you could do with it?
Yeah. So I've got quite a lot of experience in generally optimizing things. Thinking back to specifically database performance optimizations. Let's see. I don't know if I'd be able to bring any up off the top of my head, but to the point, and I think how CockroachDB would solve it is you can make online what they're called online or live schema changes. So I came into this, I created a database, I populated it with 800,000 rows, and I didn't have any indexes on it. I created indexes which wouldn't have caused downtime. But I could have also, let's say, introduced a different primary key. I could have swapped out the primary key. I could have changed data types and things like that. None of which would have resulted in downtime. Obviously, if your application is expecting one data type and it gets another, that's an application rollout you need to do as well. But let's say I want to tweak the primary key or the columns that go into a composite primary key. That's transparent to the application, so I can make quite a lot of those quite heavy-hitting changes, and the Cockroach runs those as a background job. So it will spin up another version of the table using the MVCC, multi-version concurrency control pattern. It will create two versions. It will populate the new table with the data that as you want it to be. So for example, you turn a single column primary key into a composite column primary key. And when it's finished, it will swap over to that column and then mark this one for garbage collection later.
Oh, nice.
So no downtime at all.
Nice.
So you can be in a very brownfield project, but with Cockroach, and still make quite heavy-hitting positively performance impacting changes.
Nice, and I believe you have a video explaining these changes as well.
I do. I have an online schema changes, or is it Terra-free primary key online schema changes and Terra-free foreign key changes. So if, for example, if you make a change to one table that affects another via its foreign key constraint, they're both on YouTube. Yeah. Yes, well remembered. I forgot about those.
Yeah. We might have to link them in the description. So another from the chat, over time, wouldn't an indexed table become really huge?
Yeah, it would. So let's say you've got a terabyte table, and like a large portion, let's say it's a single column terabyte table, and you've got an index on it. There'll be a terabyte worth of data in the index as well, if it's just one column. So yes, an index will have a storage performance impact, a storage impact, but there are ways around it. You don't have to just blindly keep on adding things into an index. We support what's called partial indexes. So for example, in this case, actually, why don't I'm wondering if it might make sense to show people what that means.
With the partial index?
Yeah. I'll describe it for now.
Okay.
So I could create an index over name and market, for example, in the product table, but I can specify a filter. So I'll only index things that I care about. So for example, if I've got 1 million products, 90% of which are, let's say, discontinued, I only want to index the active products, I can say create an index on this table where the status for the product, let's say a new column, is equal to active, and it would only index the active records. So if you're not no one would be searching for discontinued products, so it would, over time, the index would probably remain consistent even though you're adding new products, because other products are getting decommissioned. So it'd be like a sliding window of index size. So that would prevent your index from growing linearly with your table. You could also create row level TTL. So if you had, let's say you had an orders table, for example, or like some kind of financial ledger, legally you'd have to keep the data. Now, it depends from country to country, but I think in the UK you have to keep financial transactions for about 7 years. Obviously the Financial Services Authority wouldn't say about 7 years, they'd say exactly 7 years, but I think it's about 7 years. But you could create row level TTL to delete things after 7 years. So your data not only doesn't live, like your table won't grow beyond 7 years because you don't really care about anything like that after 7 years. You could create a CDC job to extract everything that's, you can create a CDC query that only looks for data that's over 7 years before it's deleted, or maybe 6 years, let's say, archives it off, and then it gets cleaned up. So there's a lot of flexibility you have, and with the tools available. Obviously, like, we're just scratching the surface.
Yeah.
But I think with a couple of lines of SQL, you can achieve quite a lot of really cool things.
Another question from the chat. Can you go into how CRDB stores the index across multiple nodes? Does the index travel with the range holder, etc.?
Okay, so let me just dig something out.
Sure.
I'm going to stop sharing my screen for a sec, and I'm going to just try and find something that I did a little while ago.
Yeah, you've been sharing. Oh, you're going to stop sharing?
I'll just stop sharing while I have a little root around, because no one wants to see me fumbling around in the dark looking for stuff.
I'll just switch scenes so we don't see like the large pink, or it's a purple.
What do I want to do?
But the things that you're asking, that's kind of what we're taking some time to dig into. So we know kind of more how CockroachDB works underneath. I think Rob came in with a lot of knowledge, but I think he's also finding that there's a lot more that can be learned.
Right. So I think I'm ready to share my screen again.
All right.
But this time I'm going to be... So I did a demo a little while ago. I think it's on YouTube now, on ranges in CockroachDB. And as the question asker is aware, like, it's naturally distributed, that CockroachDB was designed to be distributed. So there's no one source of truth in CockroachDB that's like a single bottleneck for the whole cluster, because a lot of replicated systems that sometimes called half distributed, they might have one master or write node with a bunch of read replicas around it. Not only then do you have eventual consistency, which might not be applicable, like appropriate for your use case, but you've also then got a single point of failure for writes. If that write node goes away, so does your ability to write to the database. With Cockroach, we share that load out across the cluster. Every node can handle writes and every node can handle reads. So I'll show you what that looks like. Let's find, I just need to do where is my query? Because these are all the steps that I used in my demo for ranges. Here we go, this is the one I need. So if I jump back into, it's just over here. Let's do a select from CRDB internal leases where the table is product. I'll tell you what that means in a minute. So I'm looking for the table ID where the table name is product. And typically, at least at the moment, I'm guessing there must be 103 tables in the system index, like within CockroachDB before we get to the user tables. And this happens to be the 104th. If I were to restart the cluster and create the table again, it would be 104. But I just wanted to do it for completeness. Next, I can run a query to show me all the ranges. So this will show me, I can actually close these down now. Let's give ourselves a little bit more space. So I can ignore. This one is just what I'll do. I'll just setting equals on. Run that again. We won't get that prompt. Anyway, so we can see at the moment, but just because this is one table and the data is less than 512 megabytes, it's all within actually one range at the moment. So what I can show from here is if I list all of the ranges, the range ID is 66. If I can show all the data that exists within that range, like this. 66? Yes. So here are some examples of the data, the actual data, how it looks. So this is the primary key index. That's a UUID hex encoded. In fact, what is it? So I just have to run this. So if I copy that whole thing, and then select the binary equivalent of that UUID, and cast it to a UUID. That's the UUID value. Nice. And it's actually the minimum UUID in the table, 000. If I look for the last lot, I would expect to see FFFF or similar. And what it's storing is the rest of the table, the rest of the value. So when I talk about the primary key lookup, this is what I was talking about. So it would use this primary key and bring out the name, finish weekly book, and the the amount 84, which is a decimal, which is the amount of the product costs, and the currency. I don't know what RSD is, but that's the currency over there. USD. There we go. That's recognizable. So, but yeah, the question about how it distributes the ranges. A colleague of mine we're actually working on a website to tell the story of distributed SQL. So expect to see something in September, October about that, exactly how it works. But at a high level, CockroachDB uses something called a distributed allocator. And essentially, you can imagine it like a colony of ants. Each node is aware of itself, and it's aware of how many ranges it has, and it's aware of its neighbors. But it's fairly dumb in that respect, because it only needs to know, for example, every 500 milliseconds, it might say, do I need to offload any of my ranges? Do I have space for more ranges? And the nodes will gossip. It's called the gossip protocol, but the nodes will gossip amongst one another to make sure data is evenly distributed amongst the cluster. Now, this is just a single node, so there's no like inter-node gossiping going on. But if this was a big cluster of gigabytes in size and there were thousands of ranges, each one of those ranges will be distributed amongst the nodes in the cluster. Each node can have 0 or more ranges, and there will be it'll be more than one range, but it would all share a portion of the data. Let's say there are 3 nodes. I would expect that each node would be a leaseholder, i.e. controller over about a third of the data. And when I say a leaseholder, I mean handles or orchestrates reads and writes for that particular range of data. So that's how we scale out for reads and writes. There's no one node that's responsible for writes. I hope that was a very, very roundabout way of answering the question.
Yeah, a lot of interesting stuff. And if you haven't, you should definitely check out Cockroach University. I think the very first course is called An Introduction to Distributed SQL and CockroachDB. And while you're waiting for the project that Rob and Paul are working on, like, check that out. And then you can, like, complete the course and put your certificate on LinkedIn and, impress your friends.
Hey, how's the channel going? Have we got any more questions?
I think we have hit them all up.
Okay.
For right now. So doing great on time. If you have any more questions. Feel free. So he just said that he has that cert. So, hey, congrats for taking that course.
Yeah, I don't have that. I don't have that certificate.
Really?
Tell me what it's like.
That's like one of the things that you're supposed to do during like molting. So whenever people start here at CockroachDB, like in our molting classes, so that's our month of learning things. Everything is cockroach termed. We're instructed to take that. New question. What about update performance?
That's a good shout. So we've covered select performance,
Mm-hmm.
and obviously it's unlikely that your database will ever be 100% read.
Mm-hmm.
So yeah, there are recommendations on how to achieve good performance over all of the CRUD, i.e. create, read, update, delete statements. For updates, we would recommend, and I think the website recommends, using upsert. If you're doing, let's say, an update of, look, I could write a pseudo query. Let's do upsert into product, and then you'd say something like name market. Then you could say values, and then that'd be a UUID, a name, blah 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 blah. Then you can have another one. So I'm demonstrating a few things here. So obviously bad SQL that won't be liked by Cockroach, but upsert is an alternative to using insert into on conflict. So insert on conflict will do a read of the table, figure out what it needs to change, and determine what to do if a conflict happens. So for example, if I had an ID of wef already in the database, I would instruct CockroachDB what to do, and I think this is quite common amongst all databases, what to do in the event that I get a conflict. So I can't insert the same data over the top of something that's going to conflict. Upsert will just overwrite the data. So it's from a purely performance specific standpoint, upsert makes sense over insert on conflict, because you get that, you don't have to do that initial read. It will just black what's in there and overwrite it. And I guess something else also, if you're regularly updating the same couple of columns, 1 or 2 columns in a database table, and let's say let's say product were to have a product image, and maybe a big old JSON blob or binary blob of data that describes the metadata of the product. Let's say you're only updating like a very small field occasionally. It would make sense for that, or even not occasionally, just however you like. If you're updating a column but not a big column, and you're never going to really imagine yourself updating those big columns, create a column family for the columns that you are just going to update. Leave out the columns that you're not going to update, because if you, by default, everything goes into the same column family. So if you're doing an update over something and it's got a big binary blob, it will overwrite that binary blob on every update, regardless of whether you're changing that binary blob or not. Now, obviously on disk that happens fairly quickly, but if you're doing lots of those, you don't want to be updating that big old binary blob every time if you're not making changes to it. So if I'm just creating the name, I would create a column family with just that name in there, and then when I make a change to update the name, Cockroach knows that I'm only updating the name column, so it'll just inject that name column over the top and leave everything else as it is.
So I think this is the first time that we mentioned column families. So I guess I can kind of gather. Yeah, what are they? I kind of gather from what you just said, but if you want to succinctly put that together.
So I think I'm not, correct me if I'm wrong, anyone on the call, but I think it might be a Cockroach specific thing. And it would essentially groups columns by their usage. So if I create a column family, I'm saying to Cockroach, I'm going to be updating this column or these columns at one time. Just be aware of it. If you don't say that, it will have to assume that you want to update everything on every write, because it doesn't know what columns you're going to be specifically modifying. So by default, there's a column family that will house everything for that row. It'll be key.id and it will contain everything else, much like the primary key index. So a column family is just like a helpful pointer that you can use, that you can create at table creation time or alter later on in the table's life cycle, just to prompt Cockroach, this is how I'm going to be updating the table, and it's primarily used for updates.
So if you are creating a table and you know that like these 3 fields are never going to change, it would be worth it to create a column family for the rest of them. Yeah,
exactly.
Is there any kind of like performance hit to creating column families? Like, would you want to have multiple ones?
I honestly don't know.
Okay.
I honestly don't know. I could definitely, you know what, let me just stop sharing my screen again, flick back to chat, and I'm just going to Google it on the side because I want to have an answer.
Yeah. It's like, shoot, I think I learned something. Now I'm going to be like going and seeing if I need to create column families for things.
Yeah, so the default behavior is when a table is created, all columns are stored in a single column family. It ensures efficient key value storage and performance in most cases. But I'm not sure about space. I don't think it mentions it. Not anything.
Yeah.
But
might just
if
be
you'd
an
like to figure
extra
it out, I can
attribute
have a look.
that gets added on. Cool. Now, good question. You didn't share your screen again, right? I don't need to hit a button.
No.
All right. Any other questions? We are coming up towards the end. We got about 10 minutes left.
Yeah.
If there are any questions, we're happy to take them. One thing from our last episode, I guess, when we were going over Roach Roast, our global app, I just want to point out that the mechanism that I used for the internationalization, it was I18 Next. I pulled all that out into its own plugin. So if you are someone writing an application and you're using Prisma to connect to the database, we recommend connecting to CockroachDB. You can use this plugin to grab your translation values from it, and so it just makes it nice and easy. But yeah, so store your translations in the database. If your database is globally distributed, you can make that translations table global, and it'd be very quick for all of your users. But I'll link that in as well. But brand new npm package. I'm getting ready to finish it out, add some testing and things like that. But
it's getting some good traction from what I can see on npm.
Yeah, like within the first like 23 hours, there were like 42 downloads, and I was like, who was doing this.
Coming from a not JavaScript world, the JavaScript com community is very active.
Yeah. Hmm. I mean, it's good and bad. Anytime I learn a new thing like that, I put it in a checklist doc. So next time I just consult the doc. That's a good way to do it. I have lots of those, and I kind of abuse the Google Drive star, and so I was like, I'm gonna star this, and then it's like I can't find anything because everything's starred. Yeah.
Sounds like you might need a partial index on stars.
Yeah. Yeah. The other thing is like my bookmarks. Like I know that I bookmark things, but they're just so unorganized, and then also the order, it's not ordered, so I need a better database for my bookmarks, I guess. Anything else that you have, anything else exciting that has happened that we can mention before we go?
New videos coming out all the time. Some videos on consistency, pitting CockroachDB up against various cloud provider databases. So that might be an interesting one for people interested in generally distributed SQL as it stands. I think in terms of what's publicly available, that's probably the main thing. I'm creating a bunch of content at the moment. The website on the distributed SQL story is going to be coming out in a couple of months. That's going to be, I think, really interesting, because we've got a lot of information, but a lot of the information is within the heads of Cockroach Labs employees, and what we wanted to do was extract that information and make it available, because we just want to tell the story, because it's an amazing product, and the way it works is equally amazing. So I think, watch the space for that, because I think that's going to clear up a lot of questions for a lot of people.
Yeah, I think this is where we say smash that subscribe button and hit the little bell, and you'll be notified anytime we publish new videos. Yeah.
Super. Well, thank you very much.
Yeah, thank you, Rob.
A pleasure, as always.
Always, yeah.
And I'll see you in a fortnight.
Yep. We had in 2 more weeks. I should have looked up when that was. Hold on. We got this. There's a calendar right here. It will be August 11th. We will be back with another episode. As always, if there's anything that you want us to go into, anything you would like us to talk about, please put it in the comments, or you can tweet at us, use the hashtag #DistributedTeaTime. But until then, I think it's time that we say TTFN.
Take care, everyone.